What is up, YouTubers? So today we are going to be testing some welders clamps, and I got these right here, which are all brand new. I got some that I've owned for a while that are older, and we're going to look at what you really get for the money, if the better ones are really that much better. And let's be honest, we know that they're going to be better, but by how much? And is there a limit to what you can spend, where if you spend a lot more, do you really get more performance? You know, there's so much to test here, so that's what we're going to tackle today. Let's get into it. So right off the bat, I want to say a thank you to you guys. I had talked about doing this in a past video or a post or something. I don't really remember. But anyways, I had a couple suggestions that worked out great because I would have never done them. And one of them is to clamp these down on something and then use a pull scale to measure how much force it takes to open them. And that's a great idea, because if you've ever used a cheap pair of these and clamped it down on something tight, you'll know that trying to pop it open, when that sucker catches finally, it'll probably break your finger. Hate that. So we're going to test that even today as well. And I bought a mini crane scale so that we can lift something with this pinched on it to get a rating of how much force until the jaws slip, which probably won't be a whole lot with these, simply because the faceplate of the pinchers is smooth. It doesn't have teeth. If it had teeth, it would hold a tremendous amount more of weight. But with that said, I also made a lifting tool for these, and you'll see that later in the video. So to start out simple, I'm going to unpackage all of these, and we're going to go from the cheapest to the most expensive and inspect each one and go from there. All right, so let's start out with a Pittsburgh, and this isn't even a Pittsburgh Pro one, if they even make it. It's the cheapest one I could get a hold of, and this is pretty typical of your like Amazon specials. Now, in this video, I didn't buy any Amazon specials to test, and the reason being is that odds are they're all crap. I mean, they're all going to be built kind of like this. So wasting, you know, $200-300 on testing 15 of them to find out that they're all probably terrible kind of didn't really interest me. And so I bought all local ones, and most of them are going to be higher end or name brand ones. So that's why I did that. Now, this is essentially kind of like a sheet metal. This is not a forged jaw. Some of the other ones do have forged jaws, and I'll show you how you can tell that and what to look for. So this is basically a heat hardenable, or you know, a hardenable steel alloy, or at least I hope it is, and it's not just straight sheet metal. Now, most of these are constructed with a pop rivet design, where like the jaws are held on with rivets. This is a little bit different than the other ones, because the other ones, I believe, are brazed from the jaw to the body, and this clearly, like you can tell by that crack there, not crack, but where it's just open air there, this is not brazed. This design is going to be by far the weakest, and like I said, this is going to be your typical Amazon special. Out of the box, it does work. I mean, it is a clamp, but in a long-term reliability, probably not the best. So the first thing I'm going to look at is I'm going to take a look at how thick it is. So the jaws on this are about 208. Let me take another reading here. Probably not even in focus. 20, so not even a quarter inch. For you metric fans, since I know a lot of you guys I watch are, yeah, about 5 mil, a little bit over. Oh, I can get this. Yeah, a little bit over there, somewhere around 5 to 5.5 mil, and this is kind of inconsistent in thickness, as are all of these going to be. So to give you an idea on thickness, this I believe is going to be the thinnest one out of all of them. So thus, in my testing, it'll be interesting to see how this performs. Now, I did buy a set of hardness testers for Rockwell, and I'm going to scratch this a little bit to get an idea of how hard it actually is. Is this really valuable information? Not really. because just because something's hard doesn't mean that it's going to be strong. It can be too hard, overly hard. Ooh. So 55, it's higher than 55. That didn't bite into it. That, I would say it's just over that. Yeah, and that definitely. So I would put, and again, I don't know how accurate this is. It's Rockwell's probably somewhere around a 61 or 62. So fairly hard jaw. And like I said, this is a heat treatable steel alloy. The construction of it, like I said, very similar to the other ones. We're going to do a lot more testing on this, but we'll do individual group testing. So let's go over to the next one. For the next one, we have the Breman, however you pronounce it, also from Harbor Freight. And the build quality of this guy seems to be significantly better than the Pittsburgh. So not only is, when you hold them, this is a lot heavier, like it actually has some material in it, but the construction is far superior. It's actually brazed up in here by the look of it. It doesn't appear to be a weld, but it seems to have a braze. The construction of it seems to be far superior. The rivets seem to be tighter, and we'll be doing slop testing on all of these too, but this overall is a lot better of a design. The jaws on this, when you look at it, this appears to be a forging. Yeah, I would edge you. Yeah, this is going to be a forged jaw. So basically, rather than just taking a stamped out piece of heat hardenable sheet steel and then heat hardening it, this has a set of dies and is hammered into shape, which produces a forging and is a lot stronger of a material to work with over just like some kind of heat hardenable sheet steel. How you tell, and I'll zoom in on this. When you look at this, now there's an initial line there, which you might think it's a casting, and this is not a casting. There's actually a secondary line. See that line right here by my fingernail? Anytime you have a wide parting line like this is going to be a forging. So it's smashed between two dies, and then they go back and just grind the edge off for the flashing the best that they can. If you ever see a single parting line and it's in the exact middle, that's going to be a casting. But this is definitely a forged jaw, so far superior to the previous Harbor Freight. So yeah, the build construction, forged jaw, it's likely going to be thicker. We'll look at that in a minute. This also has a Allen key hookup down here to tighten this when it's clamped. I'm not really sure how much that is going to benefit this, and guess what? We're actually going to test that to see if it does increase the pressure by much, and maybe how much. We'll figure that out. Now, thickness-wise, this is, you know what, I'll get it back here. About 2.72, probably a little bit thinner up here. No, actually not by much. 2.75, and in millimeter, about 6.88, 6.87 mil. So in the ballpark of that. So significantly thicker than this guy. For Rockwell hardness, grab yourself a ginger beer too if you want it. I know I have mine. All right, let's see what this is on a Rockwell scale. Yeah, so it's above, I would say above 60. And that marks it pretty good. I would say it's actually closer to 65 than 60. So we'll label this as a 64 roughly. So it is harder than that guy by a little bit. And I'm going to keep a tally on this board here in case you're wondering if you see this at any point in the video. But I'm going to, at the end of the video, I'm going to put up a whole chart so you can really look at the numbers. Now we have the Milwaukee, which this is what they call a torque lock. Once again, better build construction than the cheapest one. The jaw on this is indeed forged, much like the previous one. And as a matter of fact, I thought this was pretty interesting. I got to looking at these, and I'm pretty sure that these come out of the same factory, same manufacturer, everything. The rivets are all in the same place. The finish is almost identical. They both have the same forging mark, CRV. The jaws are identically bent. The only difference is this has like a laser engraved line and says Milwaukee. This says Breman, but these basically are the same identical thing. So that was unexpected, which will be really interesting because this Milwaukee brand sells for more than the Harbor Freight. So if these test identically, the only real benefit you would get to buying this is that it has this different lug here where you can put a bar in and spin it versus a square drive for a 1/4-inch ratchet. So you could possibly save yourself money just buying this, and really you're only getting a different bolt. But we won't know unless we test this. And that's one of the things I found. Like, you can find a factory that will build, say, 50 different of the same thing and sell it to different manufacturers. However, just because they look identical doesn't mean they perform identical. And one common thing that they'll do is they won't heat treat a lower budget one as much, or they'll use off-spec treated products. So they test them and, oh man, his batch is off-spec. Then those are the ones that they label as private brand for companies. So it's one of those things that you really, just because they look identical doesn't mean they are. So let's take a look at the thickness here. So it's about 267, 66, 265, somewhere in there. So 265, so a little bit over a 1/4 inch. For metric, that is about 6.75. This is 6.75, we'll say. So in the ballpark of the same as the Breman. Now let's look at the hardness. And that didn't even mark that really. And that marked it. So HRC scale, that actually I would say is pretty much, I would say about the same. We'll label it as a 64. So at least on face value, these two are very, very similar. So here we have the Irwin Vise Grip brand, which Irwin in general and Vise Grip has always done me well. Unfortunately, in a lot of the cases of their tools, they're all now made in Taiwan or China and don't come from the USA in a lot of cases. So that's kind of unfortunate. Now, I'm going to be testing both this one, which is the current production one, and one that I'm unsure about the age, but it's got to be at least 10 years old. I could be wrong on that, but my neighbor gave it to me, and he said he had it for a while, and so I would put its age at about 10 years old. Now, once again, this has a forged jaw. So much like the previous ones, this does not appear to be made in the same factory as these other two, or at least it's on a different production line. Not only is this indent from the forging different, but every bit of this seems to be slightly different. I have no doubt that the company that makes that used this and copied it, as most companies over in China and Taiwan do. They take a decent design and copy it. So there's a lot of similarities in the construction, the placement of pins, the way the spring hooks up. But looking over these and taking a bunch of measurements, I don't think that they came out of the same factory. I mean, even the finish is different. So unlike the previous two were same factory, this is its own unique entity. Now, the build quality of this, different finish, I would argue and say it's probably harder to make this tool than it is these. And part of that is the finish on this is so flat, it doesn't hide flaws. the real rough finish on that is going to hide a ton of flaws that you would otherwise see. So my guess is this is a little bit harder to make a decent looking tool with. The other interesting thing is this uses a Allen key on the end. The Harbor Freight version of the Milwaukee uses a quarter drive ratchet. I rather have the ratchet bolt rather than an Allen key, because I'll tell you what, I'd use an Allen key on this, set it down, and it'd be never seen again, I guess. So that's a little bit different. Well, let's get a measurement of this guy. I'll start with metric first because you guys matter to me. And I can't always make it standard first. So we're at 6.65 mil. Let's check back here. A little bit thicker back here, 6.7. I'm trying for the camera to give you guys ability to see this, so this isn't exactly accurate. 6.6. We'll call it 6.6, which in American is 0.26, roughly 0.26, 0.263. So yeah, 0.26 we'll call it, which decent thickness on that. They're actually somewhat close to one another, I guess. Now for hardness, let's start out with the 60. And that appears to have marked it pretty good, although it's possible that was just the finish on here. That marked it pretty good. Let me drop down. Yeah, I'm thinking it's just a surface finish, because this, I don't know if this isn't paint. Well, let me keep going down and see. It is possible. Again, this isn't a scientific test, and I never claim to know what I'm doing here, so. And that's still marking it. I'm going to take a guess it's just the surface finish on this, and it's not actually gouging it. So let me go back up to here and test it. And that's definitely cutting the metal. And that to me is just scratching the surface. So this is indeed, I would say, Rockwell, somewhere between 55 HRC and 60. So we'll label it at like 57. It is marking the finish up, but that definitely, the 60 is cutting into the metal. There's no question about it. And that's just kind of marring the surface, just leaving a mark. So we'll call it HRC 57. Now let's look at the older one. So here is the older Vise grip, and I was looking at these side by side, and I do notice some differences here. The screw here on the end is a little bit thinner on the older one. All the rivets seem to be in the same spot. The rivets themselves seem to be hammered a little bit cleaner on the newer one, and that's about the extent. I mean, everything else looks about identical. The finish on this is a little bit different as well. Now you can tell this thing's been welded on or around for quite some time, and it's not in the best of shape. So that may have screwed up some of the finish, but the design overall appears to be the same. But the question is, did they change any measurements as far as the thickness? So let's do metric again. So this jaw is about 6.5 mil, and I'm going to try and avoid the buckshot and BB. So hard for you guys to see this while I'm doing this. That's a BB. 6.4. Here, this one I'll just have to do 6.5. So about 6.5 mil. I'll check the other side, but yeah, it's about the same. All right, and then in inches, about 2.51. So many BBs. 0.258. Yeah, so it's in a ballpark of what the other one was as well, so not too surprising there. Now let's look at what we have for hardness. I'll start with the 55. And that didn't feel like it's biting in, just scratching the surface of the finish. So this I don't think is going to be as hard as the first three. Yeah, and that, I'll go up one and then get a feel for it. Yeah, and I can feel that biting in. So I would say this is actually a little bit harder, yeah, than the newer one, but not enough to really matter. So I'll say this is HRC 60. Yeah, so slightly harder, but that kind of difference would be found in production value. If you took a huge lot, they're going to vary plus or minus 1 or 2 HRC realistically. So I don't see that the newer one is some gross, difference compared to the older one. So that's at least good to know. All right, well, let's move on into testing. So in this next test, we're going to go through all of them and check how much deflection there is in the jaw. Now, I don't have this clamped down tight, obviously, but there isn't much slack in it. And we're just going to check back and forth with a ruler that I got. Now, this is the worn out vice grip. We're going to go in the opposite order that I tested things at previously, just kind of for fun. So we'll start here. And I'll put it centered on about the 1. And then I'm going to come back this way. I would say about an 1/8 inch in either direction. So 3.2 millimeter or about a 1/4 inch of slop in this guy. And this is a well-used product, so that's not too surprising. And that has a lot to do with how much play is back here where it's riveted. As these things wear in, they're going to get more slop. So this is a well-used one at about a 1/4 inch total slop. That's actually better than I would have thought. All right, let's set up and test the next one. So the setup I have here is I'm going to clamp each one of these down to the table 3 times, and I'm going to do a pull strength test on this handle to see how much force it actually takes to release it. Now, caveat to this, one of the things that I never mentioned to you guys, I used to compete in strongman contests, and even in my older age, I still have a tremendously good grip strength to the point that I could likely break this thing by squeezing it so hard with both my hands. And guess what? I'll do that later in the video, or at least try. But the problem I have with that is it's hard for me to know what an average person can clamp this down. And rather than being scientific and put X amount of force, all of that, I'm just going with what I feel an average person could clamp this to. So there will be natural variations between these just because I'm not a consistent animal. But with that said, this isn't a scientific test. We're just looking at some numbers, and how this geometry works, the flexibility of everything here is all going to play a role in how much force it takes to pull and release this. With that said, let's test this. About 11 pounds. So based on what I saw in this test, from face value, I believe that the Irwin Vise grip is easier to release than the other ones, even at a higher pressure. Now, part of that may be due to lever length, but actually no. So the distance from the pin to the end of the lever is identical, so that isn't necessarily why. I'm not really sure why, just the geometry is different. But generally, if it's taking less to release it, it may actually not be clamping as tight. To me, it felt it was, but that may not be the case. All right, let's keep going on with the testing. So this contraption here is what I came up to test how much clamping force these actually have. And we're not measuring the jaw pressure, but I have a piece of 1/4-inch thick tool steel that's all polished up reasonably well, and I'm clamping down with the jaws, and then there's a hook to this here dead weight, aka a 370-pound welder, and it hooks over the center of the jaw. There's a couple ways I thought about doing this, and my original thought was to use a bar stock across here, but my fear with that is under a load, it's going to pry the jaws apart. Where this hooks in there, it's actually going to pull the jaw tighter, if anything. So, because it's going to pivot off of the rivets. So this, I think, will give us at least a good comparison to how much pressure that these can squeeze. All of the pads that they grab with are approximately the same size, so a higher number on this will give us a higher reading for the pull strength. I originally wanted to use my shop press, but with the pressure gauge, but I realized that none of these could achieve 500-600 pounds of holding strength in this, so I had to resort to unconventional methods here. Now, I don't know what a normal or average reading in this would be, so this is all new, and I guess we're going to find out what would be considered acceptable. And now I did tighten these hand tight to what I would consider a very tight, maybe definitely tighter than in the previous test. So this would be like your average bear with two hands on it squeezing pretty tight. So again, there will be some variables because I'm not a consistent animal, but it should give us some interesting information. With all of that said, we're zeroed out. Let's see what it takes for this to slip at. And it's slipping at about 83 pounds is what that will hold. Yeah, about 83 is it. All right, I will off camera test these multiple times more, but this should be pretty accurate, I think. And I will Brillo pad this between tests. Well, let's get set up and do the next one. All right, to catch you guys up to speed, I'll put a kind of a breakdown of what all the test results were. My initial Milwaukee and Breman were a little bit on the low side. I tightened them up a little bit, had a little bit better numbers, but for the most part, the better clamps, aka everything other than the bottom of the barrel Pittsburgh, performed very similar. So that's good news. Now for this test, I'm just going to do it with the Milwaukee clamp, because if the Milwaukee works, then I know all of the other higher end ones will as well. But what I'm going to do is hand tighten that screw on the bottom to increase clamping pressure, and I'm going to get it good and tight and see what happens if it actually does help. What I worry about is you could probably tighten that to the point that you're going to have issues warping these jaws. I mean, even though they are forged, that could be an issue where they bend. And the other issue is when you take and put a pliers in here to release this, because you can't, you know, do it with your finger, when it lets loose, it's going to break your knuckles. So that's kind of, I don't know how useful this would be, because you'd basically have to back it off here, and that's kind of a pain. But let's find out. And actually, you know what I'll do? I'm going to take it out of this apparatus. What the hell? All right. I'm going to tighten it right here. It's actually tight enough right now that I don't know. Yeah, that's about it. Yeah, wow. I'm a little, I'll be honest, I'm a little afraid of trying to let that one loose with my finger. All right, let's see if that increases pull strength at all. And yeah, no doubt it did. I mean, it's holding 170, so that little bit that I put on there, that little bit of mustard or horseradish, definitely increases clamping pressure. The problem is, I don't know how easy it's going to be to release this. And let me put this in here so I don't have a oopsies. Yeah, that's not scary. Yeah, the practicality of that, I don't know that I'm sold on that idea. I think you're just going to end up warping even more. I mean, maybe if you have weak hands that would work, but I honestly, I don't know that that's really a benefit. And as a matter of fact, let me see if I can clamp on here without using that. Yeah, I almost think that I could get it tighter with my two hands and you could spin this down without stripping something. Yeah. All right, well, let's go back to the bench and talk about what we have so far. All right, to run through a brief kind of recap of where we're at, and we're pretty much done. I'm going to do one more kind of destructive test on this just to see if they hold up, and then we're going to go to official conclusion. But I thought I would just look at the data so far. So the overall results, and I did a ton more tests on these, but the cheap Pittsburgh, I couldn't get to go much over 90 without it, no matter how much pressure I put on it. So that's going to be the weakest by far. The rest of them, honestly, were right at between 110 and 140. The averages, I mean, for all practical purposes, I have 128 there. They're all roughly the same, the variable being me each time, but I wouldn't say there's much of a clamping difference on what you might want to clamp with those. And for the most part, all of them had similar force to release the jaw. The difference is the vice grip, both old and new, are much easier to open the jaw, significantly easier. So I find that interesting because even though they produce the same clamping force, in my little testing, they're easier to open, aka less likely to grenade your knuckles. So to me, that's a plus. Now, price-wise, the Pittsburgh being $7 without a coupon, dirt cheap. But I think by the end of this video, you're not going to want to buy one of those. The Breman, whatever the hell it is, that one being $14 without a coupon, and you could probably get it for $12. That's a hell of a deal, I think. The Milwaukee costs $10 more, and the only difference you're getting is a different way to tighten this bolt on it. And the Harbor Freight one has a quarter drive, which honestly, I rather have the quarter drive than this, in my opinion, especially because of how big this is. And of course, a vice grip is the same price as a Milwaukee. So yeah, pretty interesting results. Closer than I would have suspected, to be honest with you guys. I thought that there would be like a vast difference, but I mean, it kind of helps that two of them are from the same manufacturer unknowingly. I didn't know that when I bought them, but when I brought them together, I found out. So anyways, the last thing that I'm going to test is I'm going to go full nuclear on these and clamp them to this table with both of my hands and see if any of them survive. To put it in perspective, I would assume that I can still clamp with somewhere around 400 pounds of force pretty easily with both of my hands. I used to be able to clamp about 300 pounds of force with both of my hands. That's individually. So I would hope in my older age that I can still do 400. So we'll see what a tremendous amount of clamping pressure on these will equate. And I have a feeling that at least one of these, aka the Pittsburgh, isn't going to like it too much. But let's find out. Just so you can see, the jaws on here are straight. They haven't been damaged in any way in this testing, surprisingly. Now, I don't claim to be the best welder on YouTube or the best instructor teacher, but I can claim to probably have the strongest grip strength of any welding YouTuber. And I'm willing to put that to the test if you want to challenge me. That's about the only thing that I'm reasonably assured of, because welding in general isn't something that you can always be assured of. All right, I can get more on that. Just so you can see how much open and it's already tight. Oh, I can do more than that. The opening part's the scariest. All right. See, the problem with this thing is it flexes to the point to where I don't know that I'm going to be able. I mean, like, just let's see here. No, I can get more yet. Boy, it sounds like a musical instrument. It's so tight. Yeah, I can keep spinning this sucker down, and I don't think it's going to do anything. It's just going to flex more. Let's go some more. Yeah, I mean, I think I'm just bending this. Ooh, there we go. That's about all that thing is going to suffer right there. Any more than that, I think it's already bent the jaws pretty bad. If we'll see if it and yep, I would say that's about all it's going to take. So yeah, this guy, pretty weak. Let's go over. I know that I'm not going to be able to surpass the strength of this guy, but hey, let's do it anyways. Oh, that was about 390, 400 plus pounds it took to close that. And the jaws actually are perfectly straight. Yeah, there is a tremendous amount of tension on there. I don't even think this is going to open it. There we go. Perfectly fine. No issue whatsoever. Nothing broke back here, so we're good. We know the Milwaukee's going to pass. I'm going to save my old fingers from that. But I will try the Vise grip brand and see what that has. It's funny when you're clamping with something like this, where you can tell that it doesn't have that much flex. It like hits a hardness immediately. Yeah, no, that ain't going. Nope, still isn't going. I'll get this. Whew. Oh. Yeah. Once again, yeah, this thing is solid as a rock. I mean, the jaws aren't even flexing at all. And I can't even imagine how tight that is. I guarantee you, I don't even know that I could tighten this anymore using this. Let me go grab a quarter drive and see. I don't honestly know why you would want to do this. I don't think that it, oh, right, this is a Allen key, of course. Probably metric, too. Yeah, I'm going to end up breaking this. I can't even turn that. Yeah, this is going to break. So let's see how much force this takes to open. Yeah, by far easier than the other one. All right, well, let's go to conclusion. So I forgot to mention this thing, there is no issue with it whatsoever. So realistically, the only one that failed was the cheapest one. Couldn't handle the pressure that I put on it. And that also coincides with this guy, which I found in a bucket here in the shop. And I want to show you something. It's the same clamp as that. I don't know what happened here, but clearly there's a problem and it pulled out of here, probably broke a rivet. So I guess in conclusion, what did we learn today? Well, I learned don't waste even $10, $5, even if it's free. Don't even waste any time with these Pittsburgh clamps. They're junk. And it's kind of shocking to me that these, you could probably buy this Harbor Freight Breman brand for, I don't know, maybe 10 bucks with a coupon for one of these. That's only like $5 more than this, and you get a quality, decent product. So don't even consider these. Junk. Beyond that, I mean, I gotta say the testing of these was far closer than I would have ever expected. I came into this thinking that the vice grip was gonna blow all of them out of the water, and found out that a lot of things they're so close on that I don't know that you can really declare a winner per se. And like I had said earlier, I had no idea that this Harbor Freight and Milwaukee were literally identical minus the screw. So that was pretty wild as well. Now, I guess my takeaway on this is that if you see validity in this thing to hand tighten, which I don't know that you're going to be able to hand tighten shit if you can squeeze hard enough, maybe buy the Milwaukee. But on a coupon deal, you could buy 2 of these easily for the price of 1 Milwaukee. So my recommendation really for most of you, and it sounds ridiculous, but buy these Harbor Freight ones based on my testing and just use a 35% off like anything under $25 coupon and get 2 of these for the price of Milwaukee. They won't let you down, and if you need to use a 1/4-inch ratchet for whatever, they still work for that. So that would be my recommendation. If you want a premium one, my suggestion is to look at the vice grip. And the reason I say that is there is no doubt the handle is easier to pop off of this at the same clamping pressure as the others. I like that. And if I had to use these all day and needed to clamp down on something really hard, I would much rather have this than the other 2. So these sell for somewhere around 25 bucks, the same as Milwaukee. Honestly, I would buy this over the Milwaukee one, and you can probably get them cheaper online as well. Now, one detriment I will say to this vice grip one, this one I got from Lowe's, which I despise Lowe's, but that's whatever. The screw in here had like debris on it, and I almost need to run a tap over the screw. Like right here, it's all clean and fine, but there's like something stuck to the threads in there, and it gets a little crunchy, difficult to turn. My guess is most of them are not like that. Yeah, see, like right here, it's crunchy, difficult to turn. So that's a little bit of a disappointment, but I think whether or not all of them are like that, I doubt it. So based on what I see here, either buy this or get this one for a premium one. So with that said, if you got any comments, questions, suggestions, thoughts, feel free to leave them. Until next time.